Hi guys, in this video we learn how to write mathematics in LaTeX. Let me show you the table of contents for this video. We start by reviewing how to write and label equations. Then we move to Greek letters, parentheses, fractions, and we will see fractions and parentheses and nested fractions, square root, subscript, superscript, system of equations, summation, limit, derivatives. We will see first derivative, second derivative, partial derivative, derivative with respect to time, evaluation of the derivative, gradient. Then we will have integrals, matrix, equality and inequality, set and subset, math spaces, mathematical fonts, and optimization. Okay, so before starting, the code to structure the file as you see in this video, you can find it in the description of the first video in the playlist of LaTeX. Okay, but what you have to add, these three packages. These are the packages that I'm using for math in this video. Okay, let's start. How to write and label equations. We can write equations in different ways. First of all, we can write an inline equation by enclosing the equation between dollar marks. For example, 2 plus x equal 3, you see this is inline and we're using a dollar mark on the left and a dollar mark on the right. If we want the equation at the center of the paper, we can enclose it between two double dollar marks as follows. As you see, same equation, but we have double dollar marks and double dollar marks. Or we can use the equation environment, so backslash begin equation, our equation, and backslash end equation. In this last case, we can label the equation to refer to it. Here, we just place a label, so backslash label, and we choose a label for the equation. Now we can refer to this equation. For example, equation tilde backslash ref and the same label. And this is here, the output, equation 2. If we would just want the number in parentheses, we need to use backslash eqref. This one here. And this is from the AMS math package. So as you can see now, for example, find the solution to 2. We have only 2 with parentheses. By the way, tilde here is not really needed, but I recommend to use tilde. We already discussed about tilde in the previous video. Basically, tilde represents an unbreakable space. Okay, I'll leave you the link in the description below if you want to know more about tilde. Let's move to long equations. So if we have long equations or equations that we want to write on multiple levels, we can write them by nesting the split environment in the equation environment as follows. So here we have a begin equation and an end equation. We place a label and then we have begin split, end split. Inside here, basically, we arrange the equation as in a table, for example. The structure is the same. For example, here we have ampersand, and then we have double backslash. We start a new line, ampersand, double backslash, just like in a table. And as you can see here, we have this L on the left, ampersand equal. Then I start writing the equation. I have a plus. I want to go start a new line, so I use double backslash. And again, ampersand. I leave this space blank because I want nothing here, but note that these are aligned. And then I continue to write my equation here. Okay. Another example. Here. We have the first one, and as you can see, as I told you, just think about how you write a table. So the first input, ampersand, and the second input. Then you want to start a new line, double backslash. The first input, ampersand, and the second input, double backslash. That's it. So now let's see Greek letters. So we need a math environment for Greek letters. For example, with the dollars. So dollar, dollar, and then inside we write the Greek letters, usually preceded by a backslash. So in this case here we have alpha. So backslash alpha. What about if we don't remember the name of the Greek letter? In Texmaker, we open the structure tab at the bottom left. For example, here, and we go here. Say that I don't remember this one. This is the name. Goes here again. And that's it. Okay, let's move to parentheses. We can write parentheses and brackets just giving the input on the keyboard in the math environment. As you can see here, this is the output. Here, I just write parentheses in the brackets. Note that this does not work for curly brackets. As you can see here, I use math environment and the curly brackets, but as you can see here, we don't have any output. But let me show you how we should write parentheses and brackets. For example, compare the following two output. So we have 2 parentheses 5 plus 8 parentheses. In the second one we have 2 backslash left parentheses 5 plus 8 backslash right parentheses. Now you see here the output is the same, so what's the difference? Seems nothing, but just wait a bit. We will come back in a moment. Let's see some other parentheses. So for example here we use L brace backslash L brace backslash R brace for curly brackets, and then we use backslash L angle backslash R angle for angular parentheses. Again, if we don't remember the code, in Texmaker we go here, parentheses, and here we have the parentheses. Okay, so now fractions. So fractions are generated as follows: backslash frac curly brackets for numerator, curly brackets for denominator. So we can automatically generate the fraction by clicking here. You can see now we have the environment ready just to be filled. But honestly, I never use it. Okay, so now let's add parentheses. So we have 2 parentheses and the fraction parentheses. But look here, this is not really the output that we want. What we want is this output. And this output is rendered by \left parenthesis, \right parenthesis, because this will fit the parenthesis to the value inside the parenthesis. And this is why we should write parentheses with the left and right. Nested fractions. For nested fractions, we just need to open a new fraction in the numerator and or denominator. For example, iterate over the following difference equations. So we have y1 equal y0 over 2 plus 2. Then we have y2 equal y1 over 2 plus 2. And now what we do, as you can see, now we have a new fraction inside the previous fraction. So what do we do basically? We replace the value for y1, this is the value for y1, just copy, and what we have to put in the numerator, so here. As you can see, this is the numerator of the fraction, and we are placing another fraction, and this plus 2 here. And then we have y3 is equal y2 over 2 plus 2, and we do the same here, basically. Just copy this and replace in the value for y2. This is the output. Now, square root. Very simple. Command is \sqrt, and this is the same name as in the R programming language. However, note that when we start typing sqrt for square root, we see a square bracket for options. Let me show you. We start typing sqrt, and as you can see here, we have these brackets. Okay, and basically the brackets indicates the possibility to add options. For example, for cube root, we put a 3 in the brackets. Here, the brackets are 3, and this is the output. Now, let's see subscript. We write a subscript by using underscore and curly brackets. Note that even though subscript works with underscore only, it's not recommended to use only underscore. Let me show you why. We have here y equal beta 0 plus beta 1 x1 plus beta 2 x2 plus central dots, so \c dots, plus beta 1 2 x12. So what is the issue? Let's see in the code. Here we are writing \beta underscore 1 2, and then we have x underscore in brackets 1 2. Basically this is 12. But if we don't use curly brackets, only the first value will be taken as subscript. Okay, so that is the issue. We have just to add the curly brackets. That's why we should use always curly brackets, just to avoid any issue, any errors. Okay, subscript. We write a subscript by using the caret symbol. The caret symbol is this at here. And we should use again curly brackets also for subscript. It's just an example where we are nesting the fraction exponent. Okay. System of equations. We can write a system of equation in different ways. The simplest is to use the system package. Let me show you. This one is given by begin equation. We set a label, and then \system x plus y equal 4, 2x plus y equals 7. So we have these two equations separated by a comma. If I'm not wrong, the author of the package is a French guy. That's why system. But not the following. You see here, there's something wrong with this. As far as I understood from the package, the issue is given by these double indices. So what we can do in this case, just use an alternative way to write a system of equations. We can use aligned. So begin equation, we use backslash left backslash curly brackets. Begin align, we write our equations. When we want to start a new one, we use double backslash, then end aligned, backslash right dot. And as you can see, we fix it. Another alternative for that can be used to write a system of equations is with cases. I'm showing a different example here, but in this case is given by begin cases and cases. Okay. Now let's move to summation. We write the summation with the sum command, the underscore, and the current symbol. So this is the inline, okay? So we have just $1 mark on the left and $1 mark on the right, backslash sum underscore curly brackets I equal 1, close curly brackets, caret, open curly brackets, 10, close curly brackets, and then we have x underscore I. If we put the same summation between two double dollar marks, this is how it looks like. Okay, limit. We write the limit with the lim command and backslash 2. For example, dollar mark backslash lim underscore curly brackets t backslash 2 for the arrow here, backslash for inf t for infinity. This is another example here. It's just a nested example, but we are just using what we learned until now. So subscript, fractions, parentheses, and the limit symbol. Okay. Derivatives. For first derivative here, I'm just using the fraction environment. So fraction environment, dy dx. Nothing special here. Same also for the rest. Nothing special. Second derivative, again, nothing special because I'm just using the fraction environment and the caret symbol. I just note here, I wrote this note. Higher order derivatives follow the same pattern with the exception of fn or n greater than 3. For example, the fourth derivative, so we have f with 4 and not f with 4 or with 4 ticks, okay? Just a note. Partial derivative. In this case, we use the command partial. So here we have the fraction, and then for this symbol here, we use backslash partial. Second derivative, again, just partial and caret symbol. Derivative with respect to time. Usually we use a dot to represent the derivative of a function with respect to time. So here, backslash dot, and this is the output. The second derivative, we can use backslash d dot, and this is the output. Evaluation of the derivative. Okay, the value of the derivative evaluated at a particular point, the a, can be expressed as follows. So we have the fraction dy dx, and then here we have backslash big R with capital B, vertical line underscore curly brackets x equal a. And this is the output. For the gradient, just backslash nabla. Integrals. For integrals, we use int and the same pattern we use for summation and limits. So basically, yeah, we have backslash int underscore in curly bracket 0, then caret curly brackets. In this example, backslash infinity for infinity. This is another example here. Okay, so matrix. We write matrices with the matrix environment. So if we use begin matrix, we have just the structure. Inside the matrix, we arrange the values with the same pattern we use for building tables. So as you can see, we have ampersand, 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 ampersand. And when we want to start a new line, we double backslash and we start a new line, ampersand, ampersand. Okay, so we have these dots, have p dots, d dots for vertical dots and diagonal dots. Okay, we can add p, b, and v before matrix. For example, begin p matrix and be careful end p matrix, begin b matrix and b matrix, and here begin v matrix and v matrix. The output is parenthesis matrix, bracket matrix, vertical line matrix. In this last example here, I used begin equation and equation, but it's not really related, okay? I could use again these double dollar marks just to show you a different way. Okay, another example with lines in the matrix. So it may happen that we want to write lines in the matrix. In this case, I don't use matrix, but I use array. So what I do here is basically I use backslash left, naturally backslash right with a bracket. So I'm representing the brackets for the bracket matrix, and then begin array. So here C and C for the alignment, central alignment, and the vertical bar. And here we place a vertical bar. And then we just write an array, a table, because it's always like ampersand, double backslash. Then we have backslash each line, horizontal line, and here we place the horizontal line. Again, we put the value, ampersand, the value, and double backslash. Okay, I think that there are other ways to do this. This should work fine. Equality and inequality. For example, we have equal, different here, not equal, less, greater, less, or equal, greater, or equal, equivalent. This for we use for tilde, plus and minus, approximately. And again, if you want more symbols, let's go here. You have here one is a set and subset, and again I took this one from structure from here. So backslash subset, subset, backslash cap, slash cap, backslash in, not in, and so on. Now mat spaces. Observe the following. We're writing backslash int x dx. And then we're writing again x backslash int x space dx. But observe the output, the same, because in the math environment space does not work. We have to specifically write that we want a space. We have different options. Small space, we just place backslash comma. You see here. Medium, backslash colon. Large, backslash semicolon. Very large, we can use backslash quad. Very, very large, here backslash q quad. A mathematical font. For set of real numbers, backslash math bb. Complex numbers, backslash math bb. Also for expected value of a random variable, again, backslash math bb. Okay. For Lagrangian, on the other hand, we can use backslash math call and Hamiltonian here, backslash math call. Okay. If we go here, you see there is math here. We have font styles. So you just two. This one I show you, but you can see we have other options. Spaces. These are the one I show you. We have also math accent. Okay. This is also math function here. Let's conclude with optimization. So here we use begin equation, begin split, end split, end equation. So backslash max underscore curly brackets x1, x2, and then we write our function to be maximized. Then here, double backslash, at a new line. I'm using text because I don't want S and T as italics. So if you want in italics, just type S dot T. Quad to put the space here, and then we write the constraint. So I think we covered the most common mathematics symbols we use in LaTeX. So I hope it's interesting. Thank you for watching. See you in the next video.